Hi, this is Mrs. B. Let's review for the Chapter 7 test. So remember to pause the video and try the problems and then check your answers with mine. Here we go. We're going to work backwards this time and start with 7.5. Okay, so if we're trying to find the scale of the drawing, we always put the scale model number first. So 3 inches, and we put the actual next, so that's the 1.5 feet. And then we want to simplify that so it's to 1 inch in this case. So this way we'll know that 1 inch by dividing by 3 stands for 0.5 feet. When we're finding the scale factor, we need to compare inches to inches. So we're going to say that 1 inch, and that would go with 0.5 feet, which is 6 inches. So 1 to 6. And if we're finding the actual height of a 2.5 inch tulip that's in the drawing, we can use a proportion and use our scale. 1 inch is to 0.5 feet. In the same way that 2.5 inches is to what we don't know. So remember, we can use cross products to solve that, and 2.5 times 0.5 is 1.25 feet. Okay, for number 7, we're going to compare again the model, the 5 inches, to the 6 feet 8 inches. And we need to compare the same unit, so let's change 6 feet 8 inches into all inches by multiplying 6 feet by 12, because there's 12 inches in a foot, and adding the 72 to the 80. So we have 5 is to the 8, I'm sorry. Total it would be 80. And then we need to simplify that, just like we would simplify the fraction 5/80ths by dividing each part by 5, and we end up with 1 is to 16. And that means that for every 1 inch in the model, it would be 16 times larger in real life. Okay, I'm going to do a little bit more in 7.5. So let's practice comparing perimeters and areas also. So let's first find the scale. So we have 9 inches. We're comparing the height. So they say it's 9 inches tall, but in actual life it's 30 feet tall. So that's what our scale is 9 inches is to 30 feet. And in this case, I am going to just simplify that down to 3 inches is to 10 feet. There's no specific rule about scales except that the model comes first. Okay, we're going to use that scale in a minute, but first let's find the perimeter and area of the drawing. So I like to draw a picture to actually see it, and we have 9 inches for our height and 21 inches for our width. So in order to find the perimeter, when we add the side lengths up, we get 60 inches. And when we multiply length times width for the area, we should be getting 189 inches squared. Okay, and let's draw a picture for our actual perimeter. So if the model was 9 inches, and every 3 inches stands for 10 feet, we have to take 9 and divide it by 3, and multiply that by 10. So this is 30 feet high. And we want to do the same for the width. So 21 divided by 3 is 7, so we have 7 groups of 10 feet, so that would be 70 feet, making our perimeter crazy pen moments, making our perimeter is 200 feet. And our area is 2,100 feet squared. Okay, make sure you change your dimensions first before you figure out the perimeter or the area. Okay, let's classify a quadrilateral. So this would be a trapezoid. You're looking for the most specific name you can give for the figure. And then it said to list one characteristic of the shape. Really the only characteristic that makes the trapezoid different, it has exactly one pair of parallel sides. So you wouldn't say something like it has 4 sides, because all quadrilaterals have that, or it has 4 angles, or the angle sum. You want to say something that makes it specific to that figure. Okay, moving on. We're now at 7.4 again, and we're going to draw a quadrilateral with certain things. I do not have a protractor that I can use on the screen or a ruler, so I'm going to estimate. But the first thing I would do is make my 75 degree angle with my protractor. And I would choose my base, so it doesn't matter which side would be 4 centimeters, but I measure this side and it's 4 centimeters long. And now I need to just make it into a parallelogram by making a parallel side over here. If this angle is 75 degrees, then this angle needs to be the supplement of that, or 105. So from this vertex, I would measure 105 degrees, and it should look parallel to 75. And then we need to make sure our top is parallel to our base. So, and it should be 4 centimeters also. So yours would be a lot neater because you'd be using a ruler and a protractor. And then again, I'm going to estimate for constructing the triangle. What I do is I draw my base first. Could be any length you want it to be, because it doesn't tell us anything about the base length. And you can choose either side, but I'm going to choose the left vertex to be 65. So I would measure with my protractor something like this to be my 65 degree angle. And then from this vertex, I'm going to make a 55 degree angle, which is just a little bit shorter. So this would be my 55. And then a good way to check and make sure you've done pretty accurate measuring is to make sure the third side would give it that angle sum of 180. So this is what I come up with. And when just to review, this is a scalene acute triangle. Okay, moving on. Let's find the value of x and let's classify the shape. So it looks like opposite angles are the same, opposite sides are parallel, so we could say it's a parallelogram. And then you can get the value of x by the nature of the fact that it is a parallelogram and opposite angles are the same, so x would be 120 degrees, or you can use your angle sum of 360. Okay, let's classify and find the value of x on the triangle. So when we find the value of x, this angle sum is 180. So we already are using 90 with the right angle. So what we have left is x plus 78 must be equal to the other 90. Subtract 78 and you have x equals 12. So we have 3 different angle measures, so therefore we have a scalene triangle. So when we classify it, first let's classify it by its largest angle, which is a right angle, and then let's classify it by its side lengths. They are all going to be different because the angles are all different, so it's scalene. All right, moving on. Let's tell whether the 3 angle measures will form a triangle. They add up to 185. So no, that is not going to make a triangle. Must be 180. And then we have to tell whether the side lengths would form a triangle. Our two shortest sides, 2 plus 3, must be greater than our largest side, and it is. So yes, this would be able to make a triangle. You can also do a picture just to sort of visualize it. That if this was my 4 inches, and this is about 2, this would be about 3. We have enough length there to make the triangle pop up. Okay, let's look at 7.2. And yes, we have to decide whether first it's complementary or supplementary. Makes a straight angle, so it's going to be supplementary. Let's find the value of x by adding our two expressions together and getting a sum of 180. So x for the left angle and x minus 4 for the right angle have a sum of 180. Let's solve the equation to get the value of x. So we're going to combine our like terms. We have 2x minus 4 equals 180. We're going to add 4 to each side, and now we'll have 2x equals 184. And then the last thing we're going to do is divide each side by 2, and we have x equals 92. Ta-da! Okay, we're on our last screen now, 7.1, working backwards. So we're going to now tell whether the angles are adjacent or vertical, and then we're going to find the value of x. So on the left, yes, they are complementary also, but in this case they're asking whether they're adjacent or vertical. And since the angles are touching along this common ray, they are called adjacent. Oh, computer. And to find the value of x, we are going to use the fact that they are complementary. And x plus the other angle, 61 degrees, would have a sum of 90. So x must be 29. Okay, and then for number 5, when angles are across from each other in an x, they are called vertical. And the thing that we know about vertical angles is that they are congruent. So we can set the two equations equal to each other. So let me erase that. So I'm going to write my equation. We have x plus 42 is equal to 2x plus 1. And let's get our x's together by subtracting 1x from both sides. So now we have 42 is equal to x plus 1. So when we subtract 1 from both sides, we have that 41 is the value of x. And then you want to make sure you plug that into the angle measures to see if it really is true. And yes, the left side would have a sum of 83 degrees, and the right side would be 83 as well. So we did a good job with that. Okay, so I hope you had a good review, and I'm going to draw a picture now that you will be able to tell me the name of and get a bonus on the test. Okay, good luck everybody.